Okay, good afternoon, morning, or evening, depending on when you're watching today. This is day 6 of our integral unit, and we're basically going to look at definite integrals today. So I'll define what they are, and then we're basically look at examples again. Definite integrals are a little more practical as we start looking at them, and then in terms of doing area under the curve and things like that. So first thing that I want to do with you today is, and this will probably be one of those days where we just do the video and then next day will be the practice again. It's probably going to be that 30 to 35, maybe even a little longer video today. So let's start by first defining what a definite integral is. And basically, if we look at a definite integral, we're talking about using numbers now and numerals. Okay, so when you have an integral where you have two numbers, and we'll say b is our top limit and a is our bottom limit. So these are called our limits, or limits of the integral, we'll call them. Okay? And then if you just have some function f of x dx, this is going to end up equaling, we'll call it capital F of x. And what we usually do is we usually evaluating it for b over a, and f, this is the integral or antiderivative. Oops, spelled that wrong, didn't I? Okay, and that's that big F of x. So it represents the area under a curve. So if you had a curve like this, and you went from, say, this area here, that number there is A, and this number here is B, it will represent all this area under the curve. We call it area under the curve. Okay, so that would be all of this area here. Okay, so let's do a very simple example like x squared or something like that. So what is the area under the curve for y equals x squared from x equals 2 to 5. Okay, so if we were to sketch our curve, there's 2 and there's 5. So we want that area under the curve there. Okay, so what we got to do is we got to say this is going to be equal to, okay, we have to do the farthest limit first, top limit. As we can see, we're writing it out. B is over on the far end, so that's 5. 2. Okay, of x squared dx. Okay, it's fairly simple to do an example like this. I'll move this up so we can see it a little better. So we do the integration rule. So we go, this is equal to, okay, so we got a x cubed over 3, okay, and that's basically it plus our c, right? Now what we do in calculus is we usually just draw a bracket here to put our limits here, 5 and 2, and we plug the 5 in and we subtract 2. And this c is going to cancel each other out, because what we're going to do now is we're going to go, let's call this our capital F of x. Okay, so what we're going to do is we're going to take f of 5 and subtract f of 2, the f being this function right here. Okay, so we'll do that with this x squared here. So what does that look like? It looks like this. Okay, 5 cubed over 3 plus c minus 2 cubed over 3 plus c. Okay, so that's going to cancel out, and we're going to be left with 5 cubed over 3 minus 2 cubed over 3, which in our case, that's, what is that, 125 over 3 minus 8 over 3. And so we have that equaling, if we subtract that, 117 over 3 units squared, because it's area. And that's how you would do a basic integral, a definite integral. And you notice that the c's always cancel out. So we're going to do a few different kinds of integrals. Okay, we're going to do some basic integrals. I'll do another integral. And then maybe we'll do one that has substitution involved with it. Because when you use substitution, you're changing the variables, so you have to change your limits with it. But we'll start off with a few simpler ones here first. Okay, let's see what I got on my list there. Okay, so let's try the second example. So you want to do the definite integral from 0 to negative 3. Actually, we'll put them on the other side. That's where they're supposed to go. Because we don't want to get them confused with the constant up front. So usually it just goes on top and bottom, but most books will type them like right there. Let's go with bracket x cubed minus 9x dx. Okay, so we don't have to do any substitution for this one. This is just a larger function, so we're going to do the integral rule. So this is equal to x to the 4th, add 1 there, and then divide by it, minus 9x squared, and divide by the 2, plus the c. Okay, now we know that the c is going to cancel out, right? Because so you can eliminate it at this step if you want. Okay, because the c is going to cancel. But if you want, we'll put it in there. And then when we're going to plug it, we're going to go f of 0 minus f of negative 3. Now this is where we'll cancel the c so that we don't need it. So 0 is going to give us a 0, obviously, but let's do the function. 0 to the 4th over 4 minus 9 times 0 squared over 2. Subtract. Okay, now negative 3. It's going to be negative 3 to the 4th over 4 minus 9 negative 3 squared over 2. Okay, so this is 0 minus, what do we get here? Negative 3 times negative 3 times negative 3 times negative 3. That's going to be a positive number. What is 3 times 3? It's 81 over 4. Okay, we have 9 times 9, that's 81 over 2. Okay, we have to do a common factor to get those. Keep that minus there. 81 over 4 minus, okay, we got to multiply by 2. So 81 times 2 is 162. Still got this minus out here. I guess I could have multiplied it out here if I wanted, but I'm going to keep it to the last step. So this is going to be negative 81 over 4. And then it's negative, negative, so then you're going to get positive 81 over 4 units squared. Okay, let me just check my timer here. Make sure that we get all the good examples in today. Yeah, we should have no trouble. Okay, so that's an example where we're doing just a straight integral with 2 pieces to it rather than just the 1x squared like we did last time. Okay, let's go to the more complex one. What happens if you have to use substitution in your integral? If you do that, the limits change as well. Okay, so we did this one here. And you notice we had 0 and 3. I should have put 0, 3 here. But actually we plugged it in, so it doesn't matter. 0 and negative 3. So if you put another variable in there, it's going to change your limits. And I'll show you an example of that. So let's do an example 3 where your limits are changed, where substitution is needed. So example 3, substitution. Is used. So the key here is don't forget to change your limits. Okay, so let's do an example of what I'm talking about here. Okay, so I've got an example here. We'll use one that's got a root in it too. Integral of from 4, what do I got there? 4 to 3 of x square root 25 minus x squared dx. Okay, so in order to do this, we're going to have to do a u to do our, that's going to be 25 minus x squared. So our du dx is negative 2x. Okay, it looks like we're going to have to divide by a negative 2 to get it there. Okay, so du equals negative 2x dx. So we're going to divide by negative 2 on both sides to get du over negative 2 equals x dx. Okay, and then we're going to plug in our u. Let's do our limit change first, and then we'll do plugging in our u. So we have to change these limits. So our top limit, okay, u is equal to 25 minus x squared, which would be 4 squared, which would equal 25 minus 16, which would equal 9. So our top limit when we change to u is going to be 9. And our bottom limit, okay, our bottom limit is 3, right? So we're going to change the 25 minus 3 squared. So that's 25 minus 9. So that's equal to 16. So our bottom unit is 16. So now when we change to u, we're going to change the limits along with it. Okay, so let's go ahead and do that here. So this is, if we write this out, okay, this is 9 here and 16 here, right? Changing the limits. We're going to take the negative 2 out, or we'll just write it first. We'll go u to the 1/2, and then this, du over negative 2. Okay, we had changed our limits because we changed our variable. Keep that in mind. Okay, so now we're going to take the negative 1/2 out front. Keep our limits there, 9 and 16. And then u to the 1/2 du. Okay, if we do our integral, we get negative 1/2. Okay, so this would be adding 1/2. So we got to add 1/2 u to the, what is it here? 3/2, sorry, over 3/2. Okay, and we got to simplify that. Okay, so this is 2/3. If we divide it by 3 over 2, we're multiplying by 2/3 times that. So it'd be negative 2 over 6. So we can reduce u to the 3/2. And our limits are 9 and 16. Okay, so we're going to reduce this. Negative 1/3 u to the 3/2, 9 to the 16. So now we just use this. Okay, so we go and plug it in. It's 1/3 negative. Okay, and we're going to plug in our numbers. Okay, so so we're going to go 9 to the 3/2. And then we're going to go subtract negative 1/3, 16 to the 3/2. Okay, so this is going to be negative 1/3. Negative 1/3, come on in. I'll just, excuse me for a second. I'm going to put it on pause here, guys. Okay, let's continue. Okay, so this would be, okay, how do you do it's 9 to the 1.5 power. If you do that in a calculator, you get 27. And this is going to be plus 1/3, and this would be to 64. Okay, so we get, this is negative 27 over 3 plus 64 over 3. Okay, so we just add those two top numbers there. What do we get? 37 over 3, positive, unit squared. Okay, so there is an example of substitution being needed. So let's be aware that when you change to a u, you have to change those limits with it. And then you don't have to change back because you've already changed the limits with the u, and you can just figure out the squared units. Let's do another example here. I got a couple more that we can do. Let me look at my list here. Let's try one with a negative value as a limit and a negative exponent as a limit as well. Let's try this one. This is I'll go to a new page here. So in this example, we're going to go with where you have a negative exponent. So let's say we have integral of from 1 to 0 of x plus 4 all over x squared plus 8x plus 1 squared dx. Okay, so this is a newer type for us. Okay, so the first thing we're going to do is let's get that u. So if we say u is this bottom number, x squared plus 8x plus 1, okay, du dx equals 2x plus 8. So you can see that that's half of this top part. Okay, so if we want this top part here to be our du, we're going to have, if we divided this by 2, we'd get x plus 4, which is what that is, and that's what we want, plus du. So this would be, if we go du equals 2x plus 8 dx, and we divide it by 2 on both sides, we're going to get x plus 4 dx. Okay, so that gets us our du, and we're going to rewrite it in terms of u, so we're going to have to change the limits. So u of the top limit, 1 squared plus 8 times 1 plus 1. So our top limit is going to be 1 plus 8 plus 1, which equals 10. And our bottom limit is going to be 1, right? U for our bottom limit, 0 squared plus 8 times 0 plus 1 equals 1. So top limit of 10, bottom limit of 1. Okay, now we have to do the converting it into the u form. So here we have integral of, okay, this whole thing is going to be u to the negative 2, right? Because it's on the bottom, u to the negative 2, and then du over 2. Okay, now we're going to integrate here. So let's go this way for this one. Okay, so that means I'm going to take the half out front. And I should put my limits in there. I forgot. 10 and 1. So 10 and 1 of u to the negative 2 du. So now we have to integrate. So if we integrate, yeah, this is going to be 1 half. Add 1 to negative 2, that's negative 1, u to the negative 1 over the negative 1. Okay, and our limits are 10 to 1. Okay, we can do a little bit of simplification here of this. It'd be negative 1 half u to the negative 1, 10 and 1. Okay, now we're going to plug it in. Okay, so negative 1 half u at 10 to the negative 1 minus negative 1 half 1 to the negative 1. Okay, so 10 to the negative 1 is 1/10. Okay, so this is going to be negative 1 half times 1/10 minus negative 1 half. Okay, and a negative 1, 1 to the negative 1 is still a 1 times 1. Okay, and then we give ourselves some more space here. So we got negative 1/20th, and this is going to be plus 1. So negative 1/20th plus 1, not plus 1, plus a half, pardon me, right? Because it's 1 half, negative 1 half it's 1/2 times 1. Pardon me there. So this should be plus 1/2. Okay, so 1/2 in terms of 20ths is 10/20ths. So this would be negative 1/20th plus 10/20ths. So that's going to give us 9/20ths. Total square units. Okay, so that's another substitution one there. So we're into 25 minutes or so. Maybe I want to do just a summary here. So let's do a quick summary, and then that'll be it for today. And then I'll save the practice for tomorrow. Okay, so just to summarize, definite integral. We'll use typing. Okay, so when using a definite integral, I've got too many R's in there. With substitution, the chain rule, if you like. First thing you do is you define the variable. Okay. Then you solve for du. And do any manipulations that you might have. Okay, and once you do that, you got to change your limits to the term u. From the original integral we'll say from the original form into u limits. Okay, and how you do that is plug the value of x in, plug the limit value where x is in. For both limits. Okay, and then you would integrate the u expression and then finally you would sub your values in for u, sub your limits in for u, or calculate the area, we'll say. Okay, and that takes care of what you need to do with that. That would be the more difficult one. And we did a few examples of that. So we do have some substitution ones. I'll bring it over here and show you what your practice for tomorrow will look like. So definite integral practice with the solutions. Okay, again, there's 20 of them here. You can work on, said probably did maybe a couple of these. Do evens or odds, doesn't matter. Here are your solutions. Okay, so you can work on those tomorrow during calculus period. Do either the odd column or the even column. Don't have to do them all, or pick 5 or 6 out of here that you want to try. Make sure you pick a variety of types so that you get some practice with it. As I always say, it's best to do some practice and make your mistakes when it doesn't count for anything. And first time you try one of these is on an exam or a hand-in is not a good idea. Try them before that. Okay, so good luck with those. I'll let you work on that. That'll be tomorrow's day 7 period. And then in day 8, we'll be looking at area between curves rather than just under curves and things like that. There's a couple more days you have to go, or a few more days. I think that's There's about 12 days in here. So we'll do that next day. So we'll see you then.